Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 3 times of n plus 4 times of n plus 5 times of n plus 6 equals to 1680, and we will solve this problem for the values of n, or the real values of n. So here we find the real roots only, so that here I can first introduce the type of an polynomial. If you have some factors which is multiplied by in this form, if we have a x plus a times of x plus b times of x plus c times of x plus d equals to some constant k. So now first you remember all these factors in this way. If you add these two terms and these two terms, then you will get the same answer. If we add a plus b, then it is equals to the addition of c plus d. So now first I can rearrange these factors in this form. If I can add these factors, then you will get the same answer. So that according to this rule, we will first rearrange all these factors as. So here you remember, see that if you add 3 plus 4, it is equals to 7, and when you add 5 plus 6, it is equals to 11. So it is not equal. So if we will just add 3 and 6, if you add 3 plus 6, it is equals to 9, and if you add 4 plus 5, it is equals to 9. So now we arrange all these factors in this form: n plus 3 into n plus 6 into, because here you add 3 plus 6 9, and now we write these two factors, which is n plus 4 into n plus 5 equals to 1680. So if you add 4 plus 5, it is 9, 3 plus 6 is 9, so it is equal. So now we will arrange these factors, and now we multiply these two factors and these two factors as well. So first we multiply the first two factors, and you will obtain, here we have n squared plus 6n plus 3n plus 18 into, we will multiply these two factors and you get n squared plus 5n plus 4n plus 20, and it is equals to 1680. So now we will add or subtract the like terms, and you will obtain, this implies that n squared plus 6 and 3 equals to 9n, plus we have 18 and we write it as 19 plus 1. And similarly here you have n squared plus 5n plus 4n is 9n, and here you have 20 and we will write it as 19 and plus 1. So here you have 18 and we will write it as 19 minus 1. So I can write this term and this term, because of you see here n square plus 9 and plus 19 be the common term, so that we will write 18 and 20 in this form. So now we will just put here y equals to n squared plus 9n plus 19. So when you put this value on both of the factors, then the above factors will become in this form: y minus 1 times of y plus 1 equals to 1680. So now you will easily use the formula here, and we will write these terms as y minus 1 times of y plus 1 equals to y squared plus y squared minus 1, and it is equals to 1680. So now we move this minus 1 in the right hand side, and you will get here y squared equals to 1681. So in the next step we will take the square root on both of the sides. So when you take the square root, then you will get here y equals to plus minus 41. So here we have two cases here, and we will just break this into two factors, and you will get here y equals to 41 and y equals to minus 41. And in the next step we will back substitute the value of y, and here you see that we have y equals to n square plus 9n plus 19. So that we will back substitute the value of y, and you will obtain here n squared plus 9n plus 19 equals to 41. So this is the our first case, and here you have n squared plus 9n plus 19 equals to minus 41. So that in the next step we will make the factors of these equations, and here first we will rearrange this case, and you get here n squared plus 9n and plus 19 minus 41 equals to 0, and in this case you will get n squared plus 9n plus 19 and plus 41 equals to 0. So now first I can discuss this case, and in this case you have n square plus 9n plus 60 equals to 0. So here you remember one thing is that we will solve this problem for the real roots only. So that now first I can check is this equation has real roots or not by using the discriminant formula. So that here we have a equals to 1, b equals to 9 and c equals to 60, and our discriminant formula equals to b squared minus 4 times of ac. So now here you put the values of a, b and c here, and you check its behavior. So we have the value of b is 9, and the 9 square equals to 81, and 4 times of a is 1 and c is 60. So that when you subtract these two values, then you get here 81 minus 240. So here you easily check that it is less than 0. So if it is less than 0, then this means that this quadratic equation has no real root. So if it has no real roots, then we will reject it this case, and we will just proceed here this case only. So in this case you have n squared plus 9n minus 19 minus 41 equals to minus 22, and this whole equals to 0. So now we can find the factors by solving this equation. So now we will easily make the factors of this quadratic equation, and you will get here n squared, and we need two numbers whose product is 9, so that we write it as whose product is 22 and whose sum is 9. So we have 11n and minus 2n minus 22 equals to 0. So these are the two numbers. So here we make the factors. First you take common n, and you get n plus 11, and here you take common minus 2, and you get n plus 11 equals to 0. So now we take common n plus 11 on both of the cases, then you get here n minus 2 equals to 0. So that here we have again two cases. So first is n plus 11 equals to 0, and the second case is n minus 2 equals to 0. So in this case you will get the value of n is minus 11, and in this case you will get the value of n equals to 2. So finally we have the two values of n of the given question, which is minus 11 and 2. So these are the two real numbers or real values. So this is the our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.